Hello, dear friend, my student. Today's lecture number 2. The first chapter is Basic of Thermodynamics and its first law. So, first law of thermodynamics means uh, first law of thermodynamics whenever mechanical work is converted into heat or heat is converted into mechanical work, there exists an exact equivalence between the two. Okay, means W is equal to H. W means work done and H means heat. If both are measured in a same unit, W is equal to JH. If work is measured in a unit of work and heat is a measure in calories. First law of thermodynamics. However, practically the heat supplied to a body may not be entirely converted into work. Part of it may be used to change the internal energy of the body, and remaining part of it may be used in performing external work. Okay, just kind. However, the practically the heat supplied to a body, okay, bodyला heat supply केली may not be internally converted into work. Internally, ते work convert होणार नाही. Part of it may be used to change the internal energy. त्याच्यातली internal energy change होईल of the bodyची and remaining part of it may be used to performing external work. मग तुम्हाला ते external work मिळेल, perform होईल. Let dq be the quantity of heat observed by thermodynamic. काय dq काय आहे? हीट ऑब्झर्व करण कोण? थर्मोडायनॅमिकल सिस्टीम. आणि डी ऑब्झर्व केल्यानंतर हीट ऑब्झर्व केल्यानंतर स्ट्रेन वाढेल. म्हणजेच काय? du बी द इन्क्रीज द इंटरनल एनर्जी and dw be the external work in du be the increase it in its internal energy and dw the external work performed by the system. Then we get dq is equal to du plus dw. So graphically, this thermodynamic, first law of the thermodynamic, there is a surrounding. First, Q positive endothermic, Q minus exothermic. So work done, then system is going to heat, and when heat, delta U is equal to Q minus W. Positive W on the system and negative W work means by the system. So internal energy, what is meant by internal energy? The definition is a 2 marks, or the explanation is a 3 marks. When a piece of coal is burned, okay, कोळसा आपण बर्न केला, we get heat and light. त्याच्यातनं काय आपल्याला मिळेल? हीट आणि लाईट. तो लालसर होईल म्हणजे लाईट मिळेल. The fact suggests that some amount of energy is stored in a material. The energy stored in a substance or system is known as the internal energy. Okay. The, the total of all the possible kinds of energy of system is called its internal energy. It is neither possible or nor necessary to calculate the absolute value of internal energy. However, we can find or measure the change in internal energy when a system changes from one state to another state. It is denoted by delta U. Internal energy depend, depends only on present or current state of the system and is independent of the path by which the state was reached. So show the internal energy. This is a potential energy. When this is a kinetic energy, and then kinetic energy after internal energy. Temperature. The thermodynamic temperature is the absolute measure of temperature and is one of the principal parameter of thermodynamic. Okay, parameter आहे कोणाचा thermodynamic कोण temperature. Temperature is a parameter of the thermodynamic. The temperature is the thermodynamic variable, okay, which is used to present degree or hotness, degree of hotness or coldness of a body. आपल्याला त्याची डिग्री मोजता येते, टेम्परेचर मोजता येतं, त्या बॉडीचं किती तापलेन किती थंड आहे, किंवा हॉटनेस किंवा कोल्डनेस मोजता येतं डिग्रीमध्ये. थर्मोडायनॅमिक टेम्परेचर इज डिफाइंड बाय द थर्ड लॉ of thermodynamics, in which the theoretically lowest temperature is the null. Theoretically lowest temperature नाहीच्या बरोबर असतं किंवा नसतंच, or it may be said 0 point. टेम्परेचर स्केल काय आहे? 3 स्केल आहेत. फॅरेनहाइट, सेल्सियस and केल्विन. स्टीम ऑफ वॉटरची फॅरेनहाइट 212, सेल्सियस मध्ये 100, केल्विन मध्ये 373, and ice point of water फॅरेनहाइट मध्ये 32, सेल्सियस मध्ये 0 आणि केल्विन मध्ये 273. ॲब्सोल्यूट 0 फॅरेनहाइट मध्ये -460, सेल्सियस मध्ये -273 and Kelvin 0. So conversion of heat into work done. So when the heat is supplied to the system, then system is the expand, isn't it? Temperature is a constant. So conversions of heat into work done. We know the first law of thermodynamics. dq is equal to du plus dw. हे मिस्टेक झाले, इज इक्वल टू च्या ऐवजी प्लस पाहिजे म्हणून dq is equal to du plus dw. This is equation number 1. Now consider isothermal process. There is a T is a constant. For ideal gas, we know U is equal to F into T. So U is also constant. Then hence du is equal to 0. So equation first become dq is equal to dw is equal to 2. This is equation number 2. This process that 100% conversions of it into work. The gas enclosed in cylinder and fitted with piston undergoes A to B. Work done in this process can be evaluated. Then conversions of heat into work done during this process due to pressure P. Some force is acting on a piston is given by force is equal to P into area. Force area or apply झाला. By this process, by this force, piston displaced by small distance dx, then work done is the dw is equal to force into displacement. Work done is equal to force F into dx. Then dw is equal, you know that F काय PA into dx, and the A dx is equal to du. A dx च्या ऐवजी काय घेतलंय, du घ्यायचं आहे, चेंज इन व्हॉल्यूम सांगायचं आहे, म्हणून काय आता dw is equal to P pressure into volume. Okay, put this value in equation 2, then we get dq is equal to P dv. So various theoretically process, various thermodynamically process. The system has certain property like temperature, pressure, volume, etc. The present value of the properties of the systems are called the thermodynamic state of system. Thermodynamic process का है? When the system undergoes change from one thermodynamic state to final state due to change in properties like temperature, pressure, volume. Okay, when the system undergoes change from one thermodynamic state to final state due to change in properties like temperature, pressure, volume, etc. The system is said to have undergo undergoes in thermodynamical process. Various thermodynamical process, four types of thermodynamic process are isothermal process, adiabatic process, isochoric process, and a isobaric process. So, isothermal process, it is a change in state of system during which temperature of system remain constant is called the isothermal change. These all these in a 12th standard we are learned, or first year also we are learned this. As the temperature remain constant during this process, it obeys the Boyle's law, that is PV is equal to constant. In order to perform isothermal process, we'll have to either add or remove heat from the gas during the change, adding heat energy if it is expanded, and removing of it compressed. So isothermal process, heat is supplying, gas is the expand, isn't it? Pressure is going to decreases, isn't it? And now temperature is a constant. Isothermal, અને which one? Isothermal process. If the if the gas is compressed, dW is positive, and dq must be negative, as heat energy must be removed from the gas to keep its temperature is a constant, isn't it? The if the gas is expanded, when gas expands, the work is going to negative, and heat must going to positive. Heat energy must be supplied to the gas and to keep its temperature constant, since the temperature of the gas remain constant. Isothermal process, Tq is equal to 0. The first law of thermodynamics for such a change becomes dq is equal to w, and hence in isothermal process heat absorbed totally get converted to work done.